So quick show of hands, has anyone heard of ConcourceCI? 1, 2, 3. Anyone using it? Excellent. The project that we work on most is a comic relief donations platform, which is a globally distributed platform of sort of 25 microservices distributed to multiple platforms as services and multiple infrastructure providers globally. So we also do continuous delivery to production all the time. So our Jenkins server, as it was a large instance with lots of code to manage, all driven by Chef. Obviously, as Jenkins tends to be, ends up being a snowflake. Jenkins has no pipeline configuration as a primary structure, and also it's difficult to scale. So I think there is software as a service versions of Jenkins now, and there is scalability, but it was always difficult to do and was not really what it was built for. And there was no environment parity, so it was very difficult for developers of continuous delivery pipelines to develop Jenkins locally and then have production versions of it and all those sorts of things. And then for me, usability was always a problem. So there was a large interface with lots of screens, and configuring it was always difficult. So this was our wish list. The main wish list that we had, that it was configurable, that we could have configuration that we could easily put into Git, that was readable, that developers could iterate on, could see differences as they go along, could roll back if they needed to quickly and easily. Also that there were unpolluted builds. So I guess a lot of people just have a Jenkins server with things installed on it. I guess there is a movement towards Docker within Jenkins too, but for us there wasn't. It was either running on lots of jobs, just running on the master with services which happened to be available, or with long-lived worker, agents. And then also for us, we put everything we do through our pipeline. So all of our platforms are built from CI. All of our software is deployed from CI. When we make a change to our platform code, it deploys the platform, deploys all the code to it, runs the full suite of tests. So that was important for us. And Comic Relief doesn't have a lot of money, so it's important that we can scale. And that's both ways. So it's important that our large test environments will go down overnight and will easily come back the next morning, and we'll shut down over weekends and all those sorts of things. But when we get into the big development cycle around Red Nose Day, we also want to horizontally scale our build so we can parallelize everything and have builds coming in at 5 minutes, not 30. And again, usability is important. What we did is we switched to ConcourceCI. And one of the you'll see the user interface in a second, but one of the most important thing is that it's incredibly simple to use. The interface is 3 or 4 pages. It looks good, which is surprisingly important. The radiator's built in. You're not spending a lot of time building user interfaces and all that sort of stuff to make it look good on screens around the office. It's usable. Once you've got a broken build, getting into the exact screen where you can see why it broke is incredibly quick. Normally just 1 click, if not 2. It's all based on Docker. So all builds are inherently isolated. You cannot do anything but that, which is useful. And then no deployment is a snowflake, which is quite important. So there is no user interface at all to configure it. You cannot change a build environment by going into the interface or doing anything. Everything is through configuration and is converged onto the node. We use a tool called Bosch. Anyone using Bosch? So Bosch is a tool that's written to deploy Cloud Foundries and other distributed systems. So we use that, and we have our own CI server driving Bosch to scale itself and to scale itself down and to do updates, which is useful. And you get a good local iteration. So to drive Concourse, you have a tool called Fly, which is a command line interface. So it's easy to build a Vagrant server. It is also easy. One of the nice things is if you've got your software and you want to work out whether it's going to break your build from that directory, you can inject your code onto the CI server, and it will run your code in a Docker image exactly as it would on CI. And if that build breaks, you can also fly hijacking. So if a build breaks, you have a set period of time. I think it's configurable, but like half an hour to get into that Docker container. The Docker container lives for that amount of time. You go in and you can navigate around your application and see what would have gone wrong or what artifacts have been left around. So what you might miss if you're a Jenkins junkie, as we were, so a gazillion plugins, they don't exist yet. We probably were quite common, probably had 20 or 30. To be honest, we haven't missed them. The basics are there, Git, S3, Slack, probably quite common tool set for people. As I said, there's no runtime configuration. You cannot inject environmental variables and change config at build time. You might miss the clicking. You might miss not knowing Bosh. There's every chance if you are going to scale out a concourse, you are going to learn Bosh. You may not want that. And for me, I was new to Docker. This was the project I learned Docker on. And if you don't know that, you might not want to do that either. And then also speed. I think if you've got a long-lived worker agent environment, sometimes the artifacts that are lying around will make your build faster, which is probably an anti-pattern, but can be speedy. So if you fancied getting started, this is what you do. So you do a Vagrant init and get a Vagrant image, do Vagrant up, and that will give you a fully functioning Concourse server. Relatively performant. I certainly drove our CI pipelines for the first 2 or 3 weeks just off my local machine doing that. And then all you do to set up a pipeline is you have some YAML, you give it a name, and use the fly command to inject it in. And then locally, you'll have a running CI server. So I don't think that's an exaggeration that you'd probably have it, assuming you've got Vagrant installed. I think probably 5 minutes, and I think that's all you would need to do. So to configure a job, this is what you do. So the get is a Git resource. It goes and gets that. The input is telling you this task that you want that Git resource available. And then you just give it a Docker container that you want to go and grab. So we've got ours on Docker Hub. It'll go and grab that, and then within that Docker container, it will run a shell script. So that's just hello world, but normally it'll be something like CDing into the directory that's got your Git repo and running your, integration unit test, whatever it is. And then this is the interface that you get. So this is your main pipeline interface. So these green blobs are the tasks. So that's where the code integration tests are actually running. On the left-hand side, you've got input. So these are Git repos or version, semantic versioning constants. So they are injected into your job, and then as a result, you'll get some artifacts. We just use it with Git shars, passing Git shars down the pipeline, but it's generally designed for either publishing to Git or to an S3 in terms of producing artifacts. In terms of a task, so clicking on one of those green blobs, these are all the tasks that you would have. So this is their sort of integration thing. So you can see that it's going off, getting Gits with certain shars, running tasks, whether they're passing or not. And then if you do have a breakage, you would go into this. You'll notice that the output is all colored, which is quite refreshing coming from Jenkins. And very quickly you'll see what's happening and be able to work out why your build broke, hopefully. And if this output doesn't tell you, then it's that point you hijack into the Docker container, have a look around, see what would have broken. So there you go. Give it a go.